Alright, Assalamualaikum warahmatullahi wabarakatuh and a very good afternoon everyone. Yay, finally we are going to enter the new chapter, which is chapter 5, which is the states of matter. So this will be your second part of the lecture video for today, 4th November 2020. So we have finished chapter 4 just now. So we are going deep into this chapter, states of matter, and we are going to focus on 5.1 gas. So as you know, there are three states of matter that you guys have learned since high school, I think, or since primary school, which are solid, liquid, and gases. And today we are going to learn about gases. Okay, so in this chapter, you guys are going to learn to explain qualitatively the basic assumption of the kinetic molecular theory for an ideal gas, and define the gas law, Boyle's, Charles, and Avogadro's law. Next one, you are going to sketch and interpret the graph of the Boyle's and Charles law, and you're going to perform calculation involving gas laws and the ideal gas equation. And we are going to determine the molar mass of the volatile liquid using ideal gas equation, which has been derived using the combination of all the gases laws that you will be learn after this. And then define and perform calculation using Dalton's law. And also you guys will learn to explain the ideal and non-ideal behavior of gases in terms of intermolecular forces and molecular volume. You are going to use the van der Waals equation to explain this non-ideal behavior of gases. And lastly, we are going to explain the conditions at which real gases approach the ideal behavior of gas. Alright, so this is the introduction where we have three states of matter that we know, which is gas, liquid, and solid. And the physical properties of all of the substances often depend on its state. So like when you see the what we call it chemical equation, often that they have this phase or states in the bracket, right? So this shows us how important the states of matter of that chemical in chemistry. All right, so today we're going to learn about gas. So this is the what we call it is the gas always have pressure when we put it inside a container, a sealed container. So the pressure exerted by a gas inside the container is usually caused by the collision of the gas molecules with the wall of the container. So that is how the pressure is exerted by a gas. Okay. Alright, and the pressure actually decreases with altitude. So the higher the altitude, the lower the pressure. So like if you go up to the Gunung Kinabalu or the Gunung Himalaya, whatever, or the skyscraper thing like that, they have the very high altitude, so there is a lot lower pressure up there. So for example, at the sea level, the pressure is 1 atm. However, when you go up 4 miles, the pressure is 0.5. Up again, the pressure will be 0.2 atm. So pressure decreases with the altitude. Okay, so there are some few unit of pressure that we often use. But before that, we are going to learn how what is actually meant by pressure. So pressure is actually the force divided by surface area. So 1 Pascal or 1 PA is equals to 1 Newton per meter squared. Okay, and 1 atm is also equals to 170 mmHg and 760 torr. And 1 atm is equals to 101,325 Pascal or 101.325 kilopascal. Okay, so you need to know how to convert all this unit of pressure from one unit to another unit. Okay, so for example, when you want to convert the 749 mmHg to atm, so you guys know that 1 atm is equals to 760 mmHg. So what you need to do is 749 mmHg times with 1 atm per 760 mmHg because 1 atm is equals to 760 mmHg. So cancel the unit, then you just times and divide just like that, and you got the answer 0.986 atm. Alright, so in this chapter gases law, in this chapter gas, we are going to be what we call it, we are going to learn about the gas law. So what is gas law? This gas law is often used to describe the physical properties of gases under different conditions. So usually the four conditions or variables that we use are pressure, volume, temperature, and the amount or the number of moles of the gas. And there are actually four gases law that we are going to use. Three are the main one, which is the Boyle's law, Charles' law, and Avogadro's law. And the ideal gas law is the combination of all these three gases law. So it said that when all the gas behave under all these three gases law, it behave as an ideal gas. Okay. Alright. So, alright, this is the instrument or the apparatus used to measure the atmospheric pressure. So it consists of long glass tube closed at one end and filled with mercury. So this is the barometer. Alright, so we're going to look into the first gases law, which is Boyle's law. So Boyle's law says that at constant temperature, so Boyle's law says that at constant temperature, the volume occupied by a fixed amount of gas is inversely proportional to the applied external pressure. Alright, so P is inversely proportional to the volume. V is inversely proportional to the pressure. Mana-mana, okay? But you need to know that T and N is fixed. Okay. So this is the proportional constant. So when you convert this into the equal sign, this will become a constant K. Okay, that's why we can see that PV is equals to K, constant. Okay, all right. At under two condition, under two different condition, we can use this equation P1 equals to P1 V1 is equals to P2 V2, where this is the initial and this is the final. Alright, so the initial pressure times the initial volume is equals to the final volume and the final pressure. Alright, so this is the graph of the pressure versus molecule. So since pressure is inversely proportional to the volume, so this is the shape of the graph that you are going to draw when the question asks later on. Okay. And this is the graph of the pressure versus 1 over volume, because like pressure versus 1 over volume has this shape. Okay. Okay, directly proportional, right? So because P is directly proportional to 1 over V, betul? Okay. And this is the graph of PV versus pressure. So PV is constant. Alright. So this is the example of question. So look at this. A sample of chlorine gas occupied has a volume of 946 ml at pressure of 736 mmHg. Calculate the pressure of the gas if the volume is reduced to 154. So we know actually that this is the initial volume and this is the initial pressure. So they want us to find the final pressure given the final volume. So we can use the P1 V1 equals to P final V final. So that you can get the answer for the P final equals to how many mmHg. Okay. Next, we're going to look at Charles' law. So Charles' law states that at constant pressure, the volume occupied by a fixed amount of gas is directly proportional to its absolute temperature. Absolute zero temperature. So V is directly proportional to T. And be careful. This is the reminder to you guys that you must calculate the temperature in Kelvin. So how you want to convert from degree Celsius to Kelvin? You need to plus 273.15 to get the temperature in unit Kelvin. Alright, so just like that, just like just now, this is the proportional constant. So when you convert this into this will become a constant K. Alright, so V over T equals to K. So under two conditions, this is V1 over T1 equals to V2 over T2, where this is the initial and this is the final. Alright? Okay. Okay, variation of gas volume with temperature at constant pressure. So V is directly proportional to T, so the graph must be increased linearly, right? Is it increased linearly? I think so, yeah. Okay, so remember that the absolute zero Kelvin or negative 273.15 degrees Celsius is the temperature at which an ideal gas would have zero volume. Okay, when the temperature is 0 Kelvin, then the volume of the gas will be zero. And the absolute temperature has never been reached, okay? But physicists have attained temperature as low as 10 to the power of negative 9 Kelvin. Okay, alright. So this is the graph for the Charles law. V is directly proportional to T, and this is the what we call it graph for V versus T in the unit Kelvin. But when in unit degree Celsius, it has the extrapolating. Okay, this extrapolate. So we macam move on ke negative side. So this is your absolute temperature, okay, which is negative 273.15 Kelvin, because 0 degrees Celsius or 0 Kelvin is equals to negative 273.15 degree Celsius. Alright. Okay, let's look at this question. So it says that a sample of carbon monoxide gas occupies 320 liter at 135 degrees Celsius. So this is the initial volume and this is the initial temperature. At what temperature will the gas occupy a volume of 1.54? This is the final volume if the pressure remains constant. So they want the final temperature. So V1 T1 is equals to V2 over T2, where this side is the initial and this side is the final. Okay, alright, this one you can answer this by yourself. It has given you guys the answer. You just have to use the equation and substitute the value inside the formula. Okay, next. So the simple combination of Boyle's and Charles' law will give you the combined gas law. So which is V is directly proportional to T over P, where N is fixed. Alright, which is, then we convert this, PV over T is equals to constant. Alright, and P1 V1 over T1 is equals to P2 V2 over T2. And we can use this since we have all this, okay? This is the what call it? I need penny. So this is the V1, P1, T1, and then they got VF, TF. We can find the final pressure using the P1 V1 over T1 is equals to P2 V2 over T2. Okay? Alright. So now we're going to the third law, which is Avogadro's law. So Avogadro's law says that at constant pressure and temperature, the volume of gas is directly proportional to the number of moles of the gas present. So V is directly proportional to N, or V over N is equals to constant K. Okay. So same, under two different conditions, V1 over N1 is equals to V2 over N2. Okay. So this also we can just substitute the values inside the formula. So this is the more exercise that you guys can do it by yourself, or if you find it difficult, you can ask for your lecturer's help. You can ask me for help. It doesn't matter, siapa-siapa pun boleh tanya. Okay, more exercise. So this is the conclusion that we have learned so far, which is we have learned Boyle's law, Charles' law, and Avogadro's law. So Boyle's law yang constant adalah the temperature and amount of gas. Charles' law constant is the pressure and the amount of gas, and Avogadro's law the constant is pressure and the temperature. Okay. So yang ada table, yang ada graph, just the Boyle's law and the Charles' law. Okay. Alright, so we want to move on with the ideal gas. So what is actually meant by this ideal gas? So ideal gas is the hypothetical gas whose pressure, volume, temperature relationship can be accounted for by the ideal gas equation, also called as perfect gas. Okay, so although no ideal gas actually exists, but most simple gas such as nitrogen gas, oxygen gas, and hydrogen gas, and other noble gases show nearly ideal behavior at ordinary temperature and pressure. Okay, so how we want to get the ideal gas equation? The answer is just simple. We need to combine all these three equations from the gases law that we have learned earlier, combine it to form an ideal gas equation. Because the ideal gas equation is to describe where the gas actually behave or obey all the gases laws, which is Boyle's law, Charles' law, and Avogadro's law. So we need to combine everything. So we know that they all have the same thing, V. So V is a subject, is directly proportional to Tn over P. So we know that this is the constant, right? The proportional constant. So when we exchange it to equals, it will become PV is equals to nRT, where R is the gas constant. Okay, and gas constant, sometimes there are few value and different units. So depending on what unit this question give you, you are using that lah. Contohnya kalau unit pressure dia bagi dalam bentuk ATM, carilah gas constant yang ada ATM. Okay, and same goes like that for this one. Okay, solving gas law problems. So we have four variables with each pressure, volume, amount of gas, and temperature. So there are two main types, okay? A change in one of the four variables causes a change in another, while the two or one remaining variables are constant. So use individual gases law. So, yeah. So one variable is unknown, but three are known and no change occurs. So use ideal gas law. PV is equals to nRT. So unit for pressure, volume, universal gas constant, and temperature. So this is the list of unit lah for temperature and the pressure and the volume as well. So there is like a further application for this ideal gas where we can find the relationship of this ideal gas equation to find the density, the molar mass of gas, the pressure of gas, and the temperature of gas. Alright, so how do you want to find the density and the molar mass of the gaseous substance? So first list out what we call this ideal gas equation, which is PV is equals to nRT. Alright, then we know that this N is actually equals to this. Number of mole is equals to mass over molar mass. So when we substitute this into this, we got m over m small capital M over large big capital M V is equals to PRT. And then see here, we got MV here. We know that density is equals to M over V. So this is the density. We convert it into this. So molar mass is equals to density RT over P. Alright. So this is the final one if we want to get sampai density. If not, kalau dia switch molar mass tu, then you're good to go to just use this equation. Okay. Alright. Oh, what happened to this? Alright. Alright. So these are the question lah. You guys can do it. Yes. So we're going to move into the Dalton's law of partial pressure. So what does it mean by Dalton's law of partial pressure? It says that in a mixture of unreacting gases, the total pressure is the sum of the partial pressures of the individual gases. Ni untuk mixture yang dia tak react with each other lah. So maksudnya dia bila tak react, dia totally separate. So we can find the total pressure of each individual gas. Sorry. Okay, so for example, we got here P total is equals to pressure for nitrogen gas plus pressure for helium gas and pressure for AR gas. So all these are gas, they does not react with each other. So yeah. So P total is equals to P1 plus P2 plus P3. Okay, so this is Dalton's law. So what is partial pressure? So partial pressure of individual gas component in the gas mixture. Okay. Macam asing-asing lah kan. Contoh dalam satu bekas tu ada banyak-banyak gas. Tapi, we can find the partial pressure for each of the gases by using this equation. Okay, so now we consider a case in which there are two gases A and B and are in a container of volume V. Okay, so both of the gas is inside the container, okay, with volume V. So according to ideal gas equation, the pressure exerted by gas A is equals to PA equals to NART over V. Okay, however, pressure exerted by gas B is equals to PB is equals to MBRT over V. So they have to separate what we call it separate pressure. Okay. So to calculate the So in the mixture of gases A and B, we have total pressure sama dengan partial pressure A plus partial pressure B. So we can substitute the pressure yang kat A dengan B ni kan dekat dalam equation yang ini. Okay, so dapatlah NART over V plus NBRT over V, where NA plus NB is equals to NT. Okay, thus partial pressure of A is also given by PA is equals to XAPT. So XA is the mole fraction of gas A in the mixture. Alright, excuse me. So we can use and rearrange the ideal gas equation to form several equations. So first we got PV equals to nRT. So we can derive it in the subject as V as a subject. So V is equals to nRT over P. P equals to nRT over V. Mass equals to PV dot m over RT, molar mass, okay? And then molar mass is equals to mass times RT over PV, C equals to P over RT, N equals to PV over RT. Density is equals to PM over RT. Okay. So as for conclusion, we know that Dalton's law is the total pressure of mixture of non-reacting gases. So the total pressure of mixture of non-reacting gases is the sum of partial pressure exerted by each of the gas in the mixture. So setiap substance ada partial pressure masing-masing. Okay, but Dalton's law kata total semua pressure ni adalah non-reacting gases and total pressure of all these non-reacting gases adalah sum of partial pressure exerted by each gases in the mixture. I'm sorry. Oh my god. It's already evening. I'm sorry if I made any mistake while talking to you guys. Okay. So we know PA is equals to XAPT and then PB is equals to XBPT. So the total pressure is the total pressure is the partial pressure kan for each gas kan. So dekat sini PT partial pressure is equals to NART over V plus NBRT over V. So where NA plus NB is equals to NT. Okay, so P is equals to PT. P total is equals to N total RT over V. Okay. XA ni dia dah bagi sia-sia. Alright. So, next, we are going to move on to kinetic molecular theory of gases. Okay. So, this kinetic molecular theory of gases actually describes the behavior for an ideal gas. So, what is ideal gas? So, ideal gas is the gases which obey the ideal gas equation. Okay. So it is PV equals to nRT. So there are four basic assumptions or postulate for the kinetic molecular theory of gases. The first one, the volume of gas is negligible because since the molecule of gas is extremely small compared to the volume of the container, molecules are having mass but no volume. Kita hiraukan dia punya volume, macam tak ambil space pun dalam container tu. Okay, so volume of gas is not equals to volume of molecule gas. Alright. And then the next one is gas molecules are in constant and random motion. Maksudnya they frequently collide with each other, no energy loss, but total kinetic energy is constant lah. Alright, and molecules do not influence each other. Okay, number 3, gas molecules do not attract or repulse one another. There is no attractive forces between the gas molecules. Last one, when the temperature increases, the average kinetic energy increases. Okay, so ini tadi tu kan, yang first tadi tu, first volume of gas molecule is negligible. Second, the collision among gas are elastic. Maksudnya, the total kinetic energy before collision is equals to the kinetic energy after collision. Alright, and we know that intermolecular forces between the gas molecules is negligible. Last one, average kinetic energy of molecule is proportional to temperature of gas in Kelvin. Okay. So these are the 4 basic assumptions of ideal gases. Alright, should we continue or okay. I think, let me see first. I think we can stop here first. We are going to continue chapter 5.1 next week because the part 1 has already 28 minutes video, so this video should not exceed 32 minutes, right? Because the lecture is just 1 hour. So I think we just stop here first, and we're going to learn about this chapter, real gas, okay, which is the opposite of the ideal gas behavior. Alright, so the real guess is the guess that do not obey ideal guess equation. Ideal guess is the guesses that obey ideal guess equation. So we're going to learn how this real guess behave, okay? Alright, we are going to compare this next week. Alright, so I think we are going to stop here. That's all for today. We are going to continue the second part of chapter 5.1 and 5.2 next week. Alright, that's all for today. Thank you, class. Bye.